It's spelled, oh, this marker is kind of dying. Spelled like that. So I'm going to be for the upcoming sessions, I'm going to be the teacher for the on-site grade 7 and 8 Olympiad math, as well as the online 7 and 8, and the on-site grade 9 Olympiad. So those will be the 3 sessions that I'll be teaching. And just for today, I was told just to prepare short 15-minute sessions about some of the types of questions we've gone over in the past for the grade 7 and 8 students. So there's a few questions I prepared, not too many. Some of the students might have been familiar with the stuff they might have seen in the past. Some of the main topics that we are going to cover today, just a few questions, are geometry and some stuff related to functions. So the functions are more from the grade 8 side, because that is something in the curriculum that students start learning around grade 9. But the geometry is something that some of you might have seen in the past. So feel free to participate if you want. The questions, you may find that you have been familiar with the past. If you're not, that's fine. We're going to take our time with them. You are going to get familiar with them as we get into the sessions. Sound good? Yeah? Awesome. Let me just find one that works. Okay, that's fine. Okay, so one of the sessions we did, one of the main topics was geometry for the grade 7 class, and we focused a lot on angles and triangles, particularly the relationships that exist in various shapes, 2-dimensional shapes. So one of the, I'll just break down the question first. So the measure. So how many of you students are familiar with some of the stuff I'm writing here? Have you seen questions like this in the past? And how comfortable would you say you are with them? On a scale of 1 to 5 with questions like these?
-5.
-5, okay.
I'm like 4.
You feel good? Okay, awesome. That's good. So these are, there's some important concepts covered in this question just in terms of terminology alone. We see this word here and this word here. So it would be difficult. Have you seen something like this before? Yeah? You think so? That's fine. Again, if you haven't, don't worry at all. We're going to take our time when we, in the sessions when we do come across something new. But in this particular question, what I've underlined are 2 important concepts when it comes to angles. So it would be very difficult, if not impossible, to solve this question without knowing what these things are. So when we first saw a question like this, the way I approached it, telling the students, is to break it down to what are the main ideas that, and the main sort of unknowns that we have. And we actually have 3 unknowns here. One is the angle itself, one is its complement, and the other is its supplement. And anytime we have unknowns in sort of these math problems, I always like to write let statements or variables to represent them. So sort of approaching a question like this, I just say, let one variable be the angle. Another variable be its supplement. And one last one to be its complement. So those 3 should be all we need to solve this problem, considering those are the 3 unknowns in this question. Now before we get in, there's one important, this is sort of the main relationship that exists between the supplement and the complement. But before we get into that, it's important to understand what it means to be a supplement and complement. So does anybody remember what it means to be the supplement of an angle? No? Supplement, complement? That's okay, that's okay. So what it means to be a supplement, when one angle is a supplement to another, that means they together have a sum of 180 degrees. So if B is the supplement of X, one relationship we can come up with that is that X plus B should equal to 180. Similarly, when something is complementary to another angle, that means they have a sum of 90. So you can say that X plus A should equal to 90. And these 2 are very helpful equations that are going to help us solve this problem. Finally, another important piece of information is given in the question itself. So they tell us that the supplement is 2.5 times that of its complement, meaning we can come up with a relationship not just between X and B and X and A, but B and A. Because if B is the supplement and A is its complement, according to the statement, B should equal to 2.5 times A. So does everybody follow that and how that makes sense? So from here on, because we have 3 equations and 3 unknowns, we are actually able to solve this. And from this point on, it's more about algebraic manipulation and doing a variety of ways, maybe elimination or substitution, whatever you're comfortable with. But I'll show one way we can solve this. So at this point, because we don't know the value of a or b, we can't do anything here alone. But maybe from here we can express b in terms of x, from here a in terms of x, and then sub those expressions into here and here. And then we can solve for x from that. So if x plus b is 180, what should b equal to? Anybody? Yep.
2.5a.
Sorry?
2.5a.
So b is already 2.5a, but from this equation alone, if we want to isolate for b, what should b equal to?
180
minus x.
Perfect, yeah, 180 minus x. And likewise from here, what should a equal to?
90 minus x.
90 minus x. There you go. So now that we've isolated for b and a, we can substitute these expressions into here. And that's going to help us because then we have one equation with just x, and we'll be able to solve for the value of x, which is what the question's asking. Because it's not actually asking for the complement or supplement, it's asking for the angle itself. So we can substitute this into there. So 180 minus x should equal to, and it's a personal preference. Some people like working with mixed numbers, others with improper fractions. But I like to convert it into improper fractions. So 5 over 2 times a, which is 90 minus x. So now that we have into this form, the rest is just isolating for the value of x. You have to know about your how to, in this case, distribute a coefficient into the brackets. So this, if you end up doing the math, it should end up being 225. Subtract 5, 2x. And then nothing changes on this side. And then we're going to have to collect our like terms. So bring all the x's on one side and all the numbers on the other. So we can move the 5 over 2x over here and maybe the 180 over there. Right? So then we should have 5 over 2x, subtract a whole x, which I can rewrite as 2 over 2, just to have a common denominator. And then we can have 225 minus 180. So we're very close to the end here. That will give us 3 over 2x equal to 45. And finally, we have to get rid of this number here by multiplying both sides by 2 and dividing by 3. So our final answer looks like it's going to be 45 by 3 is 15, 15 times 2 is 30. Right? There you go. So this question was, I thought, a neat one because it deals with two important concepts of an angle. It's supplement, it's complement, and there's quite a bit of algebra involved as well. So this is just one example of the questions that we went over with the grade 7 class. There are a lot more related to this in geometry, ones with figures as well. So this one was strictly, you're given a statement and you have to come up with equations of your own. Other ones, you're given the diagram where there's an unknown and some values are known. Yeah? So how did you guys feel about that question? Good? Okay? Yeah? You good? Okay. Do we have time for one more? Yeah? Okay. So for this next question, I won't be doing another geometry one. This next question will be something we did with the grade 8 class. It is, in the curriculum here in Ontario, we learn about functions starting in grade 9, but sometimes in the Olympiad classes we like to go ahead. So in grade 8 classes we introduce functions to them. And so one of the booklets was entitled Functions. We had a lot of problems related to functions and their properties and how we can work with those properties. So this question was one of the ones we worked with the grade 8 class. Now I know if you're not familiar with this notation, if you've never seen functions before, it might look a little tricky at first. But what we're going to do, of course, is first introduce the notation and what all this means. And then that's what in the session then. So don't worry if this looks completely new to you. We are going to, because I know if you've only done grade 6 or 7, you might have never seen something like this before, right? So that's fine. Is that the case? This looks completely new?
I think I know functions.
You kind of know functions. So a very quick, very, very brief introduction will be something like this. A function is simply, you can think of it as sort of an expression or machine where we put in a value, and then based on what the rule is, we get out a different value. So in this particular case, all we have to do is to choose a number for x, and we say the output is going to be whatever we get from the right-hand side. So in this case, if I want to know, we say what is the value of the function when x is 2, wherever we see x, we simply substitute 2 there. So we'd put 2 squared In other words, 2 becomes your x. This 2 is already there, and now this is also 2. Right? And then that will become 4 plus 4, which is our 8. So that's really how we work with this function notation. Your input is what goes in over here, and then wherever you see that input anywhere else in the expression, you have to use that same number. Right? Now, right away, this actually looks a little bit different because we see we have both f's here and here. And this is a particular kind of function where the value actually depends on another value of the function. So it actually is a little trickier than simply just putting in a number. Right? But knowing what we just did over here, a lot of times when so this question, what we're trying to find is this. This is our unknown. We want to find the value of the function when the input is 6. And following what we normally do, it's almost natural for students to want to put in 6 for n, because it seems like that's the right thing to do. Right? We want to find f of 6, so let's make n 6 and see what happens. The problem we run into when we do that, though, if we make n 6, what's going to happen here? We're going to have f of 8, correct? Because if n is 6, 6 plus 2 will give us our 8. And then we get 3 f of 6 plus 4. Now, if we knew what this was, if the question told us, f in brackets 8 or f of 8 is 10 or something, then we can find what this is, right? We can move the 4 over and divide by 3. But we don't know what this is, so we're kind of stuck here. So what a lot of the students I've seen, what they try doing at this point, like, okay, we need to find f of 8. Let's put n for 8 and see what happens. Maybe we can get it. So when we put n for 8, suddenly this now becomes 10. If n is 8, this now becomes 10. And we get 3 f of 8. So it almost seems like we can never get our answer. Because every time we first try finding f of 6, but we ran into this problem where we don't know what f of 8 is. And when we tried finding f of 8, now we have f of 10. So, and it's going to continue like that. So you can see this is probably not the best way to do this question, even though it seems natural knowing that what you do with these functions is put in the number you're interested in. So the best way to actually work with this is knowing that since we're given f of 0, this should actually be our starting point, because this is actually the only value of f that we know. So instead of starting with, you're welcome, come and just get a seat wherever you feel. Way trying to put in our input of 6, maybe it would be best to put in our input of 0 because we actually have information related to that from the question, right? So we always want to try to use as much information as we can. If we just put in 6 or 8, we're actually not making use of this. And this is quite important information that can help us solve the problem. So let's, instead of putting in n for 6, put in f for 0 and see what happens then. Does that make sense? So we're not going to go down this path. We're instead going to put in 0 for n. So if n is 0, what does this part become? Correct. So we're going to have f of 2 on the left-hand side. It's going to equal to 3 times f of 0 plus 4. Now, do you see this is already better than this? Because here we had 2 f of somethings that we didn't know the value of. Here we have 2 f of something as well, but we actually know the value of this because the question gave it to us, correct? And the question told us that that's equal to 2. So we can right away make our substitution, okay, saying that's 3 times 2 plus 4, which is 6 plus 4, which is 10. So from that, we actually got more important information. We now know that f of 0 is 2 and f of 2 is 10. So just like what we did with here, that was our input because we knew its output. We can now make our input 2 because we know the output's going to be 10, right? And you can see we're slowly going to work our way up until we finally get the value that we're interested in. Does that make sense? Yeah. So f of 2 is our now the thing we want to input is 2. So let's put n for 2. 2 plus 2 should give us our 4. So now f of 4 should equal to 3 f of 2 plus 4. Again, we now know this because we just figured it out. So it should be 3 times 10 plus 4, which is 34. Right? So f4 is 34. If the question said, what is f of 4, we're done. But the question said, what's f of 6? So it seems we need to do it one more time, right? We know what f of 4 is. So if we make n 4, we should be able to find what f of 6 is. Okay? So f of 6 should equal to 3 times f of 4. 4. We just figured that out. That's 34. So what should that equal to? Anybody? That should equal to x?
Yeah.
X. So what's 3 times 34? Looks like it's 102 plus 4. Is that right? Yes? Right, so that looks like it's going to be our answer. So this was a question related to functions, but it's a unique kind of function where you don't work it within the traditional way. We have to sort of work our way up step by step. So is that okay with everybody? Yeah. So these are just some of the types of questions you can expect to see. We are going to work with geometry. We are going to work with functions in the grade 7 and 8 class. These are some questions, and don't worry if something looks tricky or scary. We're going to take our time with it. If something's new, we're going to explain it, and we'll make sure we're on the same page. Sound good? Yeah?
Good.
Okay, thank you so much, everyone.
So I have a question.
Yeah.
So that's what happens during the class?
Yeah, so it is very...
go over questions, solve it with the student?
Exactly, yeah. So in the beginning, if it's a brand new lesson, there will be like sort of like a lesson part to it instead of just doing questions right away. So if there's a new definition or new concept, we'll do like a lesson first and introduce all the new ideas, and then we'll get into practice problems after that.
Okay.
And it will be interactive, like we'll always try asking the students what they think or how they think we can solve it, and they can talk amongst themselves. So we don't want it to be just like me solving and them writing, so we want to try having some participation going on.
But then it will be hard for the online class.
Pardon?
For online class.
That will be, it'll be a little different, but I will still give time. Like, so try it for the next 2 minutes on your own, and then I'll be like, and then I'll try solving one, and they can try comparing how they do with how I did it. But we will still try to make it interactive. It will still not be just like me on the board solving problems and then just watching a screen, right? I'll give them time to work on the problems on their own too, and then yeah. So that's how we try doing it.
Sounds good.
Yeah,
Thank you.
sounds good. Thank you so much, guys.